Basically, gas turbine engine works on Brayton cycle.
Okay.
So first is compression happens.
Hmm.
Okay. So the compression happens through axial compressor. There is first stage compressor or low pressure compressor, and this sixth stage is for high pressure compressor. Okay. So here what happens? The kinetic energy of those blades is taken to the air. Okay. So it is converted into the pressure energy.
Okay.
Now, with the pressure increment, temperature also increases. Okay. Now you see here, it comes to the combustion chamber.
Okay.
You see the combustion, it is called annular combustion. It is a continuous, and the combustion is a continuous process.
Okay.
So it comes through the outer, and then there are holes are there. You can inside.
Yeah.
It comes inside, and the red portion, whatever you are seeing, they are actually the combustion takes place. Fuel will be injected, and it will be in the spray form, fine spray form, and it's very high temperature is already there. Once you ignite, it will continuous process. So now what happens is, in the combustion chambers, the fuel gets burned. So you induct energy, thermal energy. So due to that, the volume will expand. At the same time, temperature also increase. But the pressure remains same. Now the high pressure temperature gases passes through turbines. Okay?
Yeah.
So when it passes through turbines, pressure and temperature, enthalpy we call it, at your level you may not know. So that converts into kinetic energy.
Okay.
So that you see the turbine is rotating.
Yeah.
Now this turbine, the high pressure, it's called high pressure turbine, is connected with the high pressure compressor. It's the same shaft. So what happens? This compressor rotates.
Yeah.
And this low pressure turbine is connected with the low pressure compressor.
Okay.
So whatever the energy you are getting, this is self-sustaining happens. Now the remaining energy, it passes through, we call it jet pipe, and then nozzle.
Okay.
The purpose of the nozzle is, it utilizes the high pressure and temperature energy. It increases the velocity of the gases. So you get thrust. Okay. So this is the useful energy we get.
Yeah.
And the energy whatever is getting by turbine is generating, that is utilized by these compressors. Okay. So turbine is generating energy that is consumed by the compressors.
Okay.
Only the left out energy which is coming through the
That is thrust.
that is the we call is thrust.
So this blue color indicates cold air and red color indicates hot air.
See, you know what is the blue color cold temperature? What is the temperature of that? It is around 3 to 400 degrees centigrade.
This to 400 degrees. This cold
Yes,
air.
this so-called cold. And we call cold air because those air we take bypass.
Okay.
You see from the first stage, we will take the bypass. You see that casing, there are gaps.
Yeah.
Through that gaps, we will take it, and some will pass through the inside the shaft.
Okay.
And these turbine blades are very complex. There are inner serpentine roots, and there are holes, leading edge as well as trailing edge.
Okay.
So the cooling air, it passes and comes out through that.
Okay.
And it hugs the surface. That's how these turbine blades are shaped. The temperature is around 1700 degree Kelvin for Kaveri engines. So you minus around 300, so 14 to 1450 degrees centigrade. No metal can sustain.
Yeah.
And due to it is rotating around say 16,000 RPM, ISP
16,000
RPM. So few tons load will come for his blades. So at such an elevated temperature and such a tensile load, nothing can sustain.
Yeah.
So what happens? We put some coating first, and then we pull that cooling air. That is how the blade can work. Otherwise, nothing can sustain.
Okay. What is the temperature of this hot air?
Inside,
This red color.
red color, it may go even sometime. That's why 1700 degree Kelvin. We call it the inside entry of that nozzle. We call it nozzle. Before the rotating parts, one stage comes. Okay, we'll call inlet nozzle. So that.
Okay. And this Kaveri engine, in which aircraft is it used?
Kaveri engine was supposed to go with Tejas. Okay? But in between Tejas requirement goes high. And also we could not meet the whatever we made as specified. So now this is going with the UCAV, unmanned air combat vehicle. Okay,
Unmanned
combat air vehicle. So that we are now. This is called derivative. You see the nozzle is a fixed nozzle.
Yeah.
So it is called derivative. Here,
Usually these jets and all have moving nozzle, right?
variable
It will,
exhaust nozzles,
variable.
it is this one.
Okay, like
And
that.
you see there afterburners are also there.
Yeah.
So when enemy attacks or you want to go fast, we ignite the afterburner, so we get high thrust. Okay, that is not here. That is here.
Working principle of these engines are same for even commercial aircraft also, right? Boeing, Airbus and all. Principle is same.
No,
like
the
this.
principle is same, but construction will be different.
Different, yeah.
To increase more fuel efficiency and all.
Efficiency,
Okay, and this is like a commercial vehicle to a F1 car.
Yeah, got it.
So the engines will be completely different. Okay.
Made for different purposes.
Yeah, this completely different purposes. Is power to weight ratio will be very high for this.
Yeah.
You understand?
Got it. Okay. Thank you so much.
Yeah.
Thank you so much.